Good morning, dear children. Now we will move to our sixth chapter, heat and temperature. Okay, so we'll go to section A first. We'll begin with the heading itself, heat and temperature. What do we mean by heat? Already we have learned a definition for heat, isn't it? So which was that definition? First thing, heat is a form of energy, isn't it? Heat energy. Heat is a form of energy which produces the sensation of hotness or coldness. That is what we have learned, isn't it? Heat is a form of energy which produces the sensation of hotness or coldness. So when the heat is more on a body, we will say that it is a hot body. If the heat is less, we will say it as a cold body, isn't it? So the sensation of hotness or coldness will give the heat, isn't it? So that is what we have learned. Now we will move to some more standard definition for heat. Okay. Now, when you are taking a substance, it is made up of atoms or molecules, and we have already learned that the molecules in matter are always in random motion, isn't it? Molecules in matter are always in random motion. Due to motion, which type of energy is possessed? We have learned about two different types of mechanical energy, isn't it? Which were they? Kinetic energy and potential energy. So, since the molecules are always in random motion, they possess kinetic energy, and there is a force of attraction between the molecules, isn't it? What is the name given for that force of attraction? Interparticle or intermolecular force of attraction. So there is a force of attraction between the particles of matter. So due to this interparticle attraction, they possess potential energy. Okay. When you are considering matter, molecules are always in random motion. Due to motion, they possess kinetic energy, and there is a strong force of attraction between the molecules of matter, and due to that they possess potential energy. Now, the sum of this kinetic and potential energy can be called as internal energy. Okay, so it is known as internal energy, and this total internal energy of the molecules can be called as heat. Okay, so that is another definition for heat. Heat is the total internal energy possessed by the molecules in a substance. So what is internal energy? It is the sum of, here you will say it as internal kinetic energy and internal potential energy. The sum of internal kinetic energy and internal potential energy can be called as internal energy, and the total internal energy of the molecules can be called as heat. Okay, so I hope it is clear. Now, if a hot body is kept in contact with a cold body, what happens? Heat naturally flows from hot body to the cold body until both attain same temperature, isn't it? Now, with this we can give one more definition for heat. Heat is a form of energy which always flows from a hot body to a cold body. Okay, so this is another definition for heat. So we have discussed three different types of definitions for heat. First one is, heat is a form of energy which produces the sensation of hotness or coldness. Now second one, heat is the sum of, or it is the total internal energy of the molecules present in the substance. Then heat is an energy which always flows from a hot body to a cold body. So any one can be considered as the definition for heat. So we have discussed two new terms there, internal kinetic energy and internal potential energy. Due to the motion of the molecules, they possess internal kinetic energy. Due to the force of attraction between the molecules, they possess internal potential energy. Okay. So is it clear now? Now, next we will move to the unit of heat. What is the SI unit of heat? SI unit of heat is joule, isn't it? Since it is the name of a scientist and I have written the symbol, I have used capital J. If we are writing the full name, it should be written in small letters. Okay. So joule is the SI unit for what? Heat energy. It is the SI unit for any type of energy. Since heat is a form of energy, joule will be its SI unit. Now, what about the Cgs unit of heat? So, when you are learning, you should learn the Cgs unit also. Cgs unit of heat is erg. Okay, I think it is a new term for you. Erg stands for the Cgs unit of energy. Not only heat, for energy, Cgs unit is erg. And 1 joule is equal to 10 raised to 7 erg. Okay, so you should be thorough with this relation. 1 joule is equal to 10 raised to 7 erg. SI unit for heat is joule, Cgs unit is erg, and the relation connecting SI and Cgs unit is 1 joule is equal to 10 raised to 7 erg. Okay, now usually heat is not given in joule or erg, which is the commonly used or the commercial unit of heat. Commercial unit of heat is calorie, isn't it? Heat is commonly measured in calorie. And how can you relate calorie with the SI unit of heat? 1 calorie is equal to 4.2 joule. This relation is also very important. Okay. Calorie is the commonly used unit or the commercial unit of heat. 1 calorie is equal to 4.2 joule. Okay. So these are the things you should keep in mind related to heat. So which are the points? 3 different definitions for heat. Form of energy which produces the sensation of hotness or coldness, flows from a hot body to a cold body. Then next one, total internal energy of the molecules. Then speaking about the units, SI unit is joule, Cgs unit is erg. Then the relation connecting SI and Cgs is 1 joule is equal to 10 raised to 7 erg. But the most commonly used unit for heat is calorie. 1 calorie is equal to 4.2 joule. Okay. Now we will move to the next word which is given in our heading of the chapter, name of the chapter, that is temperature. So what is temperature? Temperature is the degree of hotness or coldness of a body, isn't it? If it is sensation, the sensation of hotness or coldness is heat. But how much hot or cold a body is, that is temperature. Okay. So what is temperature? Temperature is the degree of hotness or coldness of a body. Okay. Or it is the measurement of the heat. Okay. How much is that? Temperature means it tells us how much hot or cold a body is. So, definition for temperature is, it is the degree of hotness or coldness of a body. Or you can say that temperature is the quantity which decides the direction of flow of heat. Okay. Temperature is the quantity which decides the direction of flow of heat. We learned that heat always flows from a hot body to a cold body, isn't it? Now, how can you say that one body is hot and the other one is cold? Temperature, isn't it? So, if temperature is high, then you can say that it is a hot body. If the temperature is low, then you can say that it is a cold body. So, temperature is the quantity which decides the direction of flow of heat. Okay. Now, about the units of temperature. What is the SI unit of temperature? It's Kelvin. Okay. Kelvin is the SI unit, but it is used only for scientific purposes. In general, we will be measuring temperature in degree Celsius and degree Fahrenheit, isn't it? So, 3 main units for temperature. Kelvin is the SI unit, but commercial units or commonly used units are degree Fahrenheit and degree Celsius. Okay. Now, when you are considering the 3 different scales of temperature, that is 3 different units, you have to consider the lower fixed point and upper fixed point in each case. So, do you remember what is LFP and UFP? LFP means it is lower fixed point and UFP means it is upper fixed point. That is, when we are taking the measurement, we will be giving an LFP and UFP. Lower fixed point is generally taken as the melting point of ice and upper fixed point is taken as the boiling point of water. Okay, and based on this, we will give the scale. So, in these three systems of units, you should know which is the lower fixed point and which is the upper fixed point. Lower fixed point means, here I will be writing the three: Kelvin, degree Celsius, degree Fahrenheit. In these three, we should know which are the things: lower fixed point and upper fixed point. Lower fixed point means it is the temperature at which ice melts. Upper fixed point means it is the temperature at which water boils. Okay. So, first we will start with degree Celsius. What is the lower fixed point in the case of degree or in the scale degree Celsius? Here it will be 0 degree Celsius, isn't it? So, ice melts at 0 degree Celsius. So, lower fixed point is 0 degree Celsius. Now, what is the upper fixed point? It is 100 degree Celsius. 100 degrees Celsius is the upper fixed point. Now, when you are considering Kelvin scale, at what temperature does the Kelvin scale start? It starts at 273 Kelvin. So, lower fixed point or melting point of ice is 273 in Kelvin scale. Okay. And upper fixed point is 373. Now, moving to Fahrenheit scale, it is 32 degree Fahrenheit. And here it is 212 degree Fahrenheit. Okay. So these are the lower fixed point and upper fixed point in the case of Kelvin scale, degree Celsius scale and degree Fahrenheit scale. Okay. So it should be clear for you. Lower fixed point means melting point of ice. Upper fixed point means it is the boiling point of water. 0 degree Celsius and 100 degree Celsius, already we know that. Now, when you are considering Kelvin scale, it starts with 273 Kelvin. So, 273 and 373. Then in degree Fahrenheit scale means 32 degree Fahrenheit and 212 degree Fahrenheit. Now, when you take the number of divisions between the lower fixed point and upper fixed point, here it is 100. 273 to 373 means 100 equal divisions will be there. Then 0 degree to 100 degree, here also there are 100 equal divisions. Here there will be 180 divisions. Okay. Between the lower fixed point and upper fixed point, there are only 100 divisions for in Kelvin scale and degree Celsius scale. But when you are taking the Fahrenheit scale, there will be 180 divisions. Since the number of divisions between lower fixed point and upper fixed point are same in Celsius scale and Kelvin scale, when you are considering the change in temperature, that will be equal. Okay, change in temperature will be equal in Celsius and Kelvin scales, since the number of divisions between lower fixed point and upper fixed point are same. Now, I told that the change in temperature is same. What do you mean by that? Suppose you have a temperature, you are considering a temperature of 5 degrees Celsius in Kelvin scale. Okay, 5 degrees Celsius, in degree Celsius scale. Consider a temperature of 5 degrees Celsius in the degree Celsius scale. Now you are changing the temperature by 5 degree. Okay, again you are changing it by 5 degree. And if you are asked to calculate the same change in temperature in Kelvin scale, it will be 5 itself. Okay, 5, there is, you are considering degree Celsius scale. There, let the temperature be 5 degrees Celsius. Now, a 5 degrees Celsius change is brought in this Celsius scale. That is the temperature given in Celsius scale. So, what will be the new temperature? New temperature will be 10 degrees Celsius in Celsius scale, isn't it? Now, if they ask you to calculate the temperature in Kelvin scale, you should do the calculations. But if they are asking you to find how much change will be there in the temperature in Kelvin scale, means it will be same. Okay, the reason is there are 100 equal divisions between the lower fixed point and upper fixed point. So a change in degree Celsius scale will be same as a change in Kelvin scale. This doesn't mean that the temperature given in Celsius scale and Kelvin scale are same. It is different. You have to use the equations to calculate the temperature. Okay, so then next we will check that. Okay, how to calculate the or do the conversions. I think we don't have numericals from this, but anyway the conversions are important. Okay, and before moving to the conversions, one more thing. 273 Kelvin is the beginning on the Kelvin scale. Now, if we say 0 Kelvin, okay, 0 Kelvin. 0 Kelvin means it is minus 273, okay. Minus 273 will be considered as 0 Kelvin. And this minus 273 degrees Celsius, okay. 0 Kelvin means it will be minus 273 degrees Celsius, and this value or this temperature can be called as absolute 0 or 0 Kelvin. 0 Kelvin or absolute 0, okay. 273 Kelvin is the lower fixed point in the Kelvin scale. Now I am taking 0 Kelvin. 0 Kelvin means 0 degree minus, here minus 273 will come. So it will be minus 273 degrees Celsius in Celsius scale. So the 0 Kelvin or you will call it as absolute 0. This is the temperature at which entire molecular motion ceases or stops, okay, or we will say that it is the lowest attainable temperature. The temperature at which entire molecular motion ceases or stops can be called as absolute 0 or 0 Kelvin, okay. So that is another thing which you should keep in mind regarding this. What is that? 0 Kelvin. 0 Kelvin means in degree Celsius scale it will be equal to minus 273 degrees Celsius. So this particular temperature is known as absolute 0, and its importance is this is the temperature at which the entire molecular motion ceases. Okay, so please keep that in mind. Now about the conversions, it's important you should remember the conversions. How to do the conversions between Celsius, Fahrenheit and Kelvin scales. Okay, now it's very easy to convert the temperature in degree Celsius to Kelvin scale. So degree Celsius to Kelvin means degree Celsius plus 273 will give you the temperature in Kelvin scale. If a temperature is given in Celsius scale and if you are asked to convert it into Kelvin scale, what should you do? Just add 273. Okay, just add 273. That will give you the temperature in Kelvin scale. Why? Because Kelvin scale starts with 273. So just add 273 with the temperature given in Celsius scale. You will get it in Kelvin scale. Now, there is a relation connecting the Fahrenheit and Celsius scales. C by 5 is equal to F minus 32 by 9. Okay. So by heart this relation. C by 5 is equal to F minus 32 by 9. So this relation gives this equation gives the relation connecting Celsius scale and Fahrenheit scale. So if you are given a value in Celsius scale and if you are asked to calculate it in Fahrenheit scale or reverse, you have to use this equation. If it is given as 5 degrees Celsius and you should know how much it is in Fahrenheit scale, just write here 5. 5 by 5 is equal to F minus 32 by 9 and solve for F. Okay. So this is what we have to do. So is it clear about the conversions? Degree Celsius to Kelvin means just add 273. If it is between Celsius and Fahrenheit, C by 5 is equal to F minus 32 by 9. So these are the things which you have to remember. Okay. So once again, the degree of hotness or coldness of a body is called temperature, or you can say that temperature is the factor which decides the direction of flow of heat. Then Kelvin, degree Celsius and the degree Fahrenheit. Kelvin is the SI unit. Commonly used units are degree Celsius and degree Fahrenheit. Then the next thing, what is the next thing which you have to keep in mind? Lower fixed point and upper fixed point. 0 degree, 100 degrees Celsius. Then 273 Kelvin, 373 Kelvin, 32 degree Fahrenheit and 212 degree Fahrenheit. Since the number of divisions between LFP and UFP is same in Celsius and Kelvin scale, the change in temperature will be same when you are considering these two. Now, the particular temperature at which the entire molecular motion ceases or stops can be called as absolute zero or 0 Kelvin, and this will be equal to minus 273 degree Celsius. About the conversion to degree Celsius to Kelvin means just add 273. Then between Celsius and Fahrenheit, C by 5 is equal to F minus 32 by 9. Okay. Now the next thing, one more thing, the factors on which the heat contained in a body depends. It's a very important point. Heat contained in a body depends on 3 factors, that is mass of the body, temperature and the nature. Okay. Heat contained, absorbed by a body depends on 3 factors: mass, temperature and nature. Okay. So is it clear? 3 different factors on which heat contained by a body depend. Okay. Now children, you have to write question answers from this section. No need for lecture notes. So for few questions, answers are given there. Only rest you have to write. So till this means just 1 or 2 questions. Question number 1, then 4, 6. Okay, only 3 questions are coming there. Question number 1, question number 4 as well as 6. So please write this. Okay, and rest comes with the next video. Okay, thank you children.